Hey, welcome to week 8 of AI large language models. You're not used to this camera view, I know. Today, I want to teach you something very important, which is why I'm here, to teach you all about it. My name is Sanskar. I'm a startup founder of Airy AI. Do a lot of stuff with large language models locally. I've been in this space for years now, ever since the Google paper in 2017. And today, I'm going to teach you about some groundbreaking tech. Tech that you've already heard about, but I'm going to reteach it to you. It's essentially a large language model that can think. Now, let's give you a quick rundown. Okay, what do we know about large language models? Well, the first thing you need to know is that it is a neural network. Not just any, a deep neural network. So, right, I mean, I've talked about this millions of times, but why not a million more, right? So you can imagine all your neurons like this, like this, like this. Now imagine this was just incredibly deep. Like I'm talking thousands upon thousands, maybe even millions of layers, billions of layers. There's a reason why large language models have a parameter size. That's how deep that neural network is to give you the best answer, depending on its training data. Now, the thing about large language models is it's really good, and generally we call it AI because it has those AI tendencies. Have you ever watched the movie Her? It's kind of like that, right? But there's a fundamental flaw with large language models. It's the fact that it's not AI. The fact that it is called a large language model for a reason. So if we kind of take this at face value, right? Large language model. If we take this at face value, we can kind of think about it as a large language model. It's really just trying to predict the next token, okay? So if I, tell a large language model to generate a Python script on whatever training data that it was trained on, it's going to get the most likely next token from that prompt. And this gets large language models to a pretty acceptable state. Large language models are not always, accurate, but there are ways to make it accurate. And one of those ways is to incorporate reasoning, also known as chain of thought. So one way to actually look at LLMs that I like to look at as a perspective is kind of think about it as any normal human being. What do we do when we're trying to deduce an answer? We try to solve subproblems, right? And no, I'm not talking about dynamic programming. This is just kind of thinking. Think about it like this. When we play a chess game, no matter how good you are at chess, there's always a level of thinking that you have to do, okay? Let's say I'm playing the first move, I'm playing white. I have to think about what move am I going to play first. I think about what does my opponent know on how to play. Is my opponent really good at the game? Do I need to choose something that's complex, like an opening, a complex opening? Or do I, get away with something that maybe I can with a newbie? Once I choose that, I can kind of think about other things, right? I can think about, okay, do I want to play this opening to give me a certain advantage? Or do I want to play another opening to give me a different kind of pawn structure? These words might not mean nothing. They might mean nothing if you don't know anything about the world of chess. But just saying this can kind of show you how much thinking actually comes into everyday decision making. Even when you go to the grocery store, you have to think, what ingredients do I need? And subconsciously, you're guiding yourself towards the aisle of the grocery store, towards how do you pay at the cash register, and so on and so forth. This is called a chain of thought, and this is in human psychology. So it only makes sense if we incorporate the same logic into a large language model. Let's kind of break it down. So, in recent years, there was a company called DeepSeek. Well, it wasn't them that started it first, so let me rewind it really quick. The first reasoning model that came out that really shook the world was from a company named OpenAI. You might have heard of them, I don't know. They're kind of obscure. And essentially, they created this model called O1. And O1 was kind of a breakthrough because they finally introduced this thing called chain of thought, which, again, essentially breaks a problem into subproblems, like that grocery example and the chess example I gave you. So, when we think about chain of thought, how do we think about it when all an LLM does is generate the next token? See, that's the funny thing. you can alter what tokens get generated based on a different prompt. Again, we're trying to break down a prompt into separate prompts. So just like how we think about, I need to go to the grocery store, we think about, we go into the car and we start driving, we press on the gas pedal, we press, go on this certain speed, we blink. All these things are subconscious. An LLM can do the same thing, but with differing prompts. And with differing prompts, you can get a chain of thought. There's actually a recent paper, a little bit of a sidetrack, a recent paper that goes over something called the atom of thoughts. And essentially, they do this exact same study, but on smaller models. And they find out that reasoning models actually work really well when you apply the same logic to small models. Now, it's very similar to how O1 works. But we know O1. The bigger hit was actually from DeepSeek that released a open source version called R1. That was huge because reasoning was behind closed doors from OpenAI. Then some Chinese company came in and kind of wrecked everything with R1 for a good thing. It's good for us. And now we kind of know how this all works. So let's kind of think deeper. When we think about the next token, how does it actually get that next token? If I gave you a prompt, if I gave DeepSeek a prompt or OpenAI a prompt, say, generate a calculated Python script. Without a reasoning model, it's just going to use the top K answers, dependent on the temperature. If the temperature is high, it might be a little bit more random. If the temperature is low, it's going to give you the answer closest to its training data. That's how an LLM works. But with reasoning, it's going to convince itself with a new prompt, breaking that prompt that you gave it into a prompt an LLM can best understand. I'm sure you guys have used O1 before, or even R1, and you can actually see this chain of thought happening in real time. It's essentially an LLM telling itself what it needs to do. And they actually do this and alter the training data such that it can understand its own language to best understand how to solve a problem. So it's kind of like going to the grocery store and remembering to take your grocery bag with you. It's the same level of logic. So, if we look at top K elements, this is essentially the this is essentially a leaderboard of the next token. You can actually make this far more accurate if you have a better prompt. There's a reason why prompt engineering exists. This is exactly why, to alter this, such that you always get the best elements here. And that's why reasoning was a thing, right? To give you that chain of thought. Now, where is this actually applicable? The thing is, it's kind of applicable everywhere. There are certain places that it actually excels at. Stuff like Q&A, question and answering, reasoning has skyrocketed in the benchmarks. You can kind of think of math and science. It can better reason or better hallucinate itself. There are caveats to these things, but generally it is better at answering prompts. And there is a limitation to this. It's the fact that whenever you use a reasoning model for an extended period of time, I'm saying not time exactly, but extended period of prompts, many prompts at a time, you will actually encounter more hallucinations than not. And the reason for this is it all depends on a large language model's context window. A context window essentially gives it a number of tokens that it can use for a response. It can range from about 4K, 8K, to like 1 million. I believe the LLM that has the largest context window is Gemini. So you can actually pass in an entire code base to Gemini. It'll probably give you the best answer from any LLM out there. But the thing is, whenever you do reasoning, all that reasoning goes into your context window. So if you're giving a fairly large prompt and then it does a fairly large reasoning, it's actually going to shorten its own context window such that if you have a long conversation with it, it's going to lose important context. So in that regard, a traditional LLM might actually be better for longer conversations and more deep, provoking conversations. which is kind of ironic, thinking that it's a reasoning model, right? It should have all this context. So, anyways, that's a little bit about reasoning models. Thank you for listening. I'll see you next week.